All right, so we're up to this chapter now, beginning chapter 8. And I'll mention these slides. My videos are moving off of YouTube onto Dailymotion because YouTube is kicking me off again. They don't want me around, so I cannot have them nuking my lectures that way, so I'll put them on LastPass, Dailymotion, which seems to be more tolerant.
What is Dailymotion?
It's an alternative to YouTube. It was apparently around earlier. It's the number 2 video streamer, and they are not as anxious to kick everybody off all the time. YouTube is very harsh at kicking off lots of people, and this is the 3rd time they threatened to kick me off, so I'm getting the message that my days there are numbered.
Are they making money from like YouTube?
Both of them supposedly make money, yeah, by putting ads on, yeah. But they have only like 15% as many users. YouTube is the giant. But because of that, YouTube is under great political pressure to censor it. And they're implementing clumsy AIs that censor things sloppily and hit a lot of collateral damage, and I'm the collateral damage. So anyway, I got to move to a different melting ice flow to stand on while it melts under me, which is the internet for you. Anyway, so...
That's for being a hacker.
Well, yeah, but they're not mad at me for being a hacker. They only took down one video like 3 years ago for being a hacker. They're mad at me for having a podcast where we discuss COVID medical articles. They keep flagging me for COVID misinformation because their AI cannot parse a sentence. So if you say something about COVID, they figure you're lying and kick you off. And that's apparently this is well known. People tell me other podcasters have learned to use like code words for COVID so that you don't get kicked off.
Oh, you mean that AI is recording?
The AI is look at the recording and decide that you're saying something about COVID and it must be disinformation. Because they like showed 100 videos of like the alt-right yelling about COVID, and it looks like you're saying something that resembles that to the AI, so they kick you off. Which is all they can do. I mean, that's why I can't hate them too much. They're just trying to avoid having Congress come down on them like a ton of bricks and ruin the business. So they're trying to do some kind of content moderation, and they're implementing whatever's most cost-effective, which is some kind of AI that's right maybe 90% of the time and wrong 10% of the time, and who cares? It's a free service, right? I can't really complain. But my 6 years of hacking videos will all vanish when they kick me off, so that's rude. Anyway, all right, so we're going to talk about the vulnerabilities of Android devices, mainly the pre-installed applications. And a few more things here. We'll go through the first third of this chapter. I broke it up into 3 pieces again. So your pre-installed applications are your most likely way to get in. I mean, the actual operating system itself gets cleaned up pretty much by Google. So there are mistakes, but they aren't that many. But the applications are typically thrown together sloppily by one manufacturer, thrown on, not really tested. And the same thing's true of computers. Your default HP Print Manager and our strange cloud service, and those things are typically crappy apps that crash and have vulnerabilities. The junkware they blowed up your machine with, and they blowed up your phone with random junkware too. And they typically block the updates. So so each app has its own attack surface. Normally, apps do not run as root. There are occasionally Android devices sold that are running as root. And the first iPhone did run as root, but there was no app store. The only software was Apple put on there, so it wasn't much of risk. When they started having the app store, they lowered the privileges, and that's, of course, the case there. But even if you don't get root privileges, sometimes you can exfiltrate user data, although, as we've talked about, every app runs in its own account. And is supposedly not going to be able to read the data from another app, but there are some exceptions. And that's what you do if you find a powerful app that has more than usual privileges. If an app has install packages, then that app has a right to install packages, of course, and that is the Android package has that. And so that would, if you have that, then the app can install more malware after it. And when I looked, your Drozer had the ability, this pen testing framework that we're not using now, it doesn't seem to be maintained, but it did have the ability to look for apps with installed packages, and it found a few on here, like Google Play Store obviously has that. You can go in Google Play and click a button and it installs an app. That's what it's for, and other things do too. And like I say, the emulator has just a native image of Android from Google with nothing else on it. And that's not got too many of these mistakes made, but a real phone has a bunch of proprietary stuff from the phone manufacturer, which usually does have these foolish permissions. And I think the point of this, by the way, is that if you wanted to have your own custom update process, instead of sending people to the Google Play Store to update, you'd have to have the ability to install packages within your app. All right, so here's apps running a system that have high privileges, and there's a few of them. These are all, there's something called System Patcher. This must be Genymotion's. I was using a Genymotion emulator, and that must be their updater or something. And then various Android devices run as system. So those also have high privileges. And then there's remote attack vectors. So if you want to attack somebody remotely, which is almost always what you want to do, I mean, there's a category of attacks that require you to physically steal the phone, but that is, a very limited attack and very rare compared to network attacks. And so tricking the user into installing malicious app is, of course, the number one obvious way to do it. This keeps happening all the time. You can even put malicious apps in the Google Play Store and get away with it quite a while before they'll catch you. And a bunch of people load stuff not in Google Play Store, especially in other countries like in China where the Great Firewall blocks the Google Play Store. You have to use third-party app stores, and it's real easy to get malware into there. Then you can attack the server side, a listening port. If you have a listening port on it, you can attack it. And you can also get people to open a malicious document, like a malicious PDF, in a vulnerable PDF reader or that sort of thing, or a web page. So those are various ways to get in. And browsers and document readers have always been very vulnerable. There's an endless chain of PDF vulnerabilities and other ones. The problem is these things have complex parsers, and they're usually written in a native code, which is C++ or something. So Samsung's PDF viewer was vulnerable. My emulator didn't have any PDF viewer on the training motion emulator, but you could put one on, and then they tend to be vulnerable. So here's the apps running a system. On my machine, we've seen that before. It's not that exciting, but anyway, there are many more devices. There's a page in your book with many apps running on a real phone. And this is one of those things where it probably would be better to use a real phone to do the research. Same thing's true of malware analysis. You have to use a real phone. You can't use an emulator. The malware is smart enough to know it's on an emulator, and it doesn't run. Sending remote attack vectors. I think we've already been here. All right, so browsable activities. These are activities that can open a URL and display it, so they act as a browser. And as I mentioned before, an enormous number of apps have a browser inside them, which is sort of insane. This means you have 100 copies of a web browser on your phone because they just don't work together very well. So that's an issue. And of course, the App Store has this functionality. You can open a link. Yeah.
Is that related to the web view that you mentioned last time?
Yes, absolutely. That means it's running a WebKit or a WebView or something inside the app. It's running a whole renderer inside the app, and typically it's out of date and doesn't have all the correct settings. So
we don't want to implement the web view.
Everybody does, because it makes your app look prettier. It makes you have a better customer experience. Now you click on Facebook, it opens Facebook in the app. You don't leave the app. You still know you're in the app. This way they retain control of you. They can track you and sell the tracking information for money. And when you're done looking at Facebook, you're back in the app again. So the user experience is so valuable that they put up with the security consequences. But what it does mean also is you have now inherited the responsibility of maintaining a browser security inside your app. And many app developers are not really up to that. But they don't know, or they don't care. Most likely they don't know. Most developers are pretty naive about security, and most managers are pretty naive about security. They just want it to work and get out there, and they think of security as something that will happen later. All right. Anyway, so you can go in, and here's a rogue Drozer agent. Drozer has the ability to generate apps to install on a device with special privileges. I think I'm planning to do something like that this semester. I think we'll just do it with Metasploit. Like I say, my Metasploit against Android is just as effective as Drozer. But anyway, here it defined an activity that was browsable. So it received messages from the web. And this is a way to launch your malicious app from a URL. However, it won't let you launch apps from an iframe anymore. There used to be a time when you could put up an iframe which had a Skype : / phone number in it, and anybody that viewed the web page, their Skype would call that phone number. And they caught on to that and began to put some defenses against it. So you cannot automatically launch apps just from an iframe on a web page anymore, because that's just asking for too much trouble. So you can have a pwn URI or a web intent that does this. This thing here defines a pwn prefix, a method, which is down here, pwn. So if the schema comes in a pwn : / it will launch this app. Yeah?
What if someone, if they had a malicious site where you would use something like that, what if you just put some DOM element that covers the entire screen that's hidden, and then when they click on the screen thinking they're doing something else, they go to something like that?
Yes, that's a UI redress attack. That absolutely works. It's a big deal. What you do is I'll just read it for people remotely. You put up a link and you put something else on top of it. So they think they're playing a game or something, they're actually clicking on a link. Those really work, and those are hard to stop. Well, I see some questions here. People asking why YouTube skipping. I told that. Yeah, okay. Chinese. Yeah, what'll happen is the Daily Motion links are going to be on the page. So I'll mention this. Right now, I've got these YouTube videos here. And so those are just going to be links to Daily Motion, not embedded frames anymore, starting now. So you'll just see link here, go here with the video, go here for the video. That's all. That'll be better anyway. A bunch of people pointed out to me that some browsers don't render these very well anyway. So anyway, that'll be my plan for the time being, unless Daily Motion kicks me off. But from what I understand, Daily Motion will not kick me off. It's just YouTube that is very, very big on this cancel culture stuff. And I know why they are. I follow the politics. They kind of have to be. But, you know, it reminds me of the important fact, which is I'm of no importance. I didn't pay anything. I can't complain. Nobody cares. I'm just a minor thing to be shrugged off if I'm inconvenient. And, you know, you're going to...
You're a freeloader.
I'm just a freeloader. So, you know, I shouldn't really trust them. And I've heard many, many painful stories about how I was bad running my business. I was making all this money, and YouTube canceled me. And they won't tell me why. And I'm crashed now. And I don't want to be that guy. So, anyway, it totally happens. Now people are asking, you think the S-bombs on Security Weekly? Well, I don't think they're actually helping yet. Security software bill of materials. This is the current attempt to try to deal with supply chain attacks, and that's in its infancy. There's hope that it may eventually improve security, but right now it's too new. It's like DNSSEC. It's something that will help when it's fully implemented, but when it's in the early stages, it's just a theory. Anyway, so all right, and I looked to see which apps use browsable, and there were quite a few things. Fidelity was browsable. It had a Fidelity : / you could open something. That's interesting. That might be worth looking into. So you can launch the Fidelity app, and Blackboard, which is a teaching platform like Canvas, has them. So anyway, they're browsable. They have their own URL scheme to launch things. So that might be a vulnerability. I don't know. It's hard to say. You have to see how they implemented it. And here's what I say, custom update mechanisms. You might decide you want to have custom updates, especially, I'd say, if you consider how many manufacturers block other updates and how rarely people actually go to the Play Store and update their apps. I never do, even on the... So you can make your own update mechanism, but then you're going to have to install packages. Your app's going to have that ability, and therefore, if your app has a security flaw, the hacker can use it to install other packages. And this is what happened with the attack we've been talking a lot about on Paul's Security Weekly of bring your own vulnerable driver. People write drivers for like a hard drive or something, and then if the driver is poorly written, it's running in the kernel with system permissions, and people can use it years later that have nothing to do with your company as malware. They install this driver, which will go on because it's signed, and now they use it to attack your machine. So I think this is a fairly common situation that developers do not understand the security consequences of their decisions. Like when you decide to put a browser in your app, they don't think of what could go wrong. And when you decide to make your app have a custom update, they don't think about how your app now has an extra power that you're probably not really responsible enough to handle correctly. Yeah.
This is kind of unrelated, but are these custom update mechanisms more popular in like iOS apps? Because I know there they take like, you need to like submit your app for review every time, I think. I could be wrong, but I know it takes a long time, so it could be more convenient.
It's a good question. You ask if these things are used in iOS to circumvent their painful approval process. I do know that Uber violated their rules and got busted and threatened to be kicked off the iOS years ago. I know the iOS rules are much stricter and they're much harsher about them. And I would think they would try to stop these custom updates. Certainly, I think you'd get in trouble on iOS a lot sooner. iOS really likes to control what you're doing. This is, in fact, how iOS lost its no malware thing on the Mac. Macs used to advertise like 4 reasons to buy it. Number 1 was no malware. And then they didn't let Java have their own update. Java tried to update with pop-up updates. And they said, no, we can't have Java popping up updates. They have to go through the Apple official update. And they held it back for 6 weeks. And then at that time, an exploit came out. And they had malware on the so the bullet point vanished. And, you know, it's, but they're very much against having the user irritated by all these pop-up update this, update that in the Apple platform. They're all about the user experience. Yeah. Anyway, so for example, if you check for a new file without really securing the connection, that's one of the many flaws. When you put on your update, you might not really use good HTTPS to update it, and then somebody can insert malware in it. Then there's this thing, Dex Class Loader. Kind of mind-boggling to put this in here. This is the method that will load code off the internet and run it within your app. It's like code injection, just by default, deliberately designed to do this. Of course, so are Java applets, which is why Java is the way to take over the machine. So, and they say, don't let the web server cache these things because the web server caches are not protected. So someone could just replace your stuff on the server, so they begin to become aware of the vulnerability of loading code from a live website and running it within your app. But we're going to see a lot of ways to do that. It's remote loading of code. So this is the Java Reflection API. Loads code over the network or from a local application. And therefore, if anybody can tamper with that code coming in, they've got code injection. And web views. So here's a recipe they talk for disaster. Use a web view, which is a browser inside the app. Then you define a JavaScript interface. Then you load, in some insecure way, code from the internet. And now, if you're on an older version of Android, this means not only can I run code in your app, but I can run operating system code and get to the operating system files through your app. That's what they fixed after in Android API 17, which is pretty old now. In API 17, they changed it. They restricted this method. Now, the earlier method, you could run arbitrary methods of Java objects, including running commands on the operating system underneath. So you had command injection on the OS, but in Google's fix in API 17 was this: you must add the @JavaScript interface annotation to any method you want available to your JavaScript. So the default system ones will not have that annotation and will not be executable in this fashion. So that will lower the harm of using this to where they can only mess with your app, not with the underlying OS. So that is an improvement. And of course, there's listening services, which we saw with that ES file sharer app, file explorer app. If you're running an app, it can just open a listening port on the network and take data from the network, and it can have vulnerabilities that way. And so here you see there are only a few running on my default system, but again, it will be a question of what apps you've installed or what apps your phone manufacturer installed. So then there's message applications. These, of course, are taking external packages of data, and often those have vulnerabilities. On the first, I guess the only Windows phone had a really serious SMS vulnerability. There was an SMS of death that would just reboot your phone. It kept happening a lot to people. And so all these are taking, also email and chat, they're all just taking data from the internet, and there are frequently exploits where a malformed chat message will crash your machine. I've seen like two during the pandemic, there were two like Wi-Fi attacks where all you had to do is change your Wi-Fi access point to something that would like kill the iPhones and kill the Android phones that connected because it had some funny malformed Unicode characters in there. These kind of things happen anytime data is coming in from the outside. So if you want to find these vulnerabilities, then you download the apps, convert them to readable source code, search for vulnerabilities, for patterns in the source code. That's one way to do it. There are scanner modules in Browser. I didn't leave them in the course because they didn't seem to work that well. They have some attempt to do vuln scanners. I think we're finding better vuln scanners now. We covered a few in the projects. And Drover had a SQL injection scanner, but it didn't seem to work worth a damn. It wouldn't even work on the sample app that they provided, so I wasn't very impressed. There are a lot of commercial vulnerability scanners, though, that people use for web apps, like one I've been using is NetSparker, which now has changed its name to another name, in Teaser or something. But that's a nice one. That's a highly inexpensive commercial one, but it works fine against web apps, and I imagine it could go against Android and iPhone apps too. So, to exploit your device, there's remote exploits. This is where you get a foothold, so you find some way to actually get code on the device. If you go to the attack framework, this is one of the early steps. I have some way to get code on your device. A man-in-the-middle attack, malware, get you to click on a link. And then there's local exploits. The remote exploit gets me from the internet onto your device. A local exploit lets me do something further on your device, which is typically privilege escalation. I'm on there, but I'm just one app or the user. I want to elevate to root. And so that's what a local exploit would do. All right, so there are attacks, a lot of attack tools out there. EtherCap is the classic one, and there are many others that will put ARP packets out to redirect traffic on a local wireless network to your machine. So you can put yourself in the middle, so now you can read and modify traffic that's passing through if it's not encrypted. This was all the rage until about 5 years ago, when everybody pretty much moved to HTTPS and made this almost useless. If you really have proper HTTPS with verifying the certificate, then being in the middle doesn't really do you any good, unless you are a nation-state actor or a very powerful actor who can actually get a real certificate authority signature. You can't really do much from that position in the middle. Burp, of course, what we're using here, can inspect and modify traffic. And if you use something like EtherCap, in our case, we modify the phone to send the traffic to Burp in the settings. And that's just for test purposes. If you wanted to attack somebody else this way, you would modify the network with ARP to make it come to your man in the middle. And you could do that, but again, then you would find that you get warnings on their browser and their app, if it's well designed, warning them that you have your attack in the middle. Although, as we've seen, a lot of apps do not verify the HTTPS certificate, and then HTTPS does them no good at all, because they'll believe my fake certificate and use the wrong key. Yeah?
What does ARP stand for?
Address Resolution Protocol. So when you try to send data to the internet, your computer has to send it to the router, which is the only way out, but your computer can only direct traffic by MAC address. Local area networks only let you use layer 2 addresses, and MAC addresses are random. So even though you know the IP address of the router, you cannot send any data to it. You know it's 192.168.1.1, but you don't know its MAC address. So ARP is how you find out. You send out an ARP request saying, what is the MAC address of the router? Then an answer comes back. The problem is that's a really old protocol. It does it with broadcast, and it does it with no encryption and no signature. So anybody else can lie, and your devices will all believe it. All routing of traffic on a switched network with ARP is on the honor system. You assume nobody's lying. So you can totally claim to be the router and put yourself in the middle. So you can redirect all traffic to come to you, and there's no effective defense against this anywhere.
It's like hacking off the network or on the network.
Yeah, you have to be on the same network. You have to be physically close, but you can redirect all traffic to go through your machine. You can put yourself in the middle. You can make it so you're on the path to the internet. And then you can tamper with any traffic that's not encrypted, or any traffic that is encrypted with HTTPS that does not verify the certificates, which, as we've seen, many apps have that flaw. And then HTTPS does not in fact protect you at all, because you just run Burp or any other tool that puts out a fake certificate, and my browser will encrypt it, but with a key that came from you, not from the real server. Then you re-encrypt it and pass it on to the server. The server has no idea anything happened, and I have no idea anything happened, but all my data is passing through you, and you can read it and modify it. So that's pretty awesome, and it'll work if the developer did not verify the HTTPS certificate, which 5 to 10% of apps don't. So it's a problem. And I've tried to explain this to a whole lot of app developers with very little success. But a couple of people have actually been busted by the Federal Trade Commission and fined for this. They've said, breaking HTTPS is in fact such a lousy form of security, it does not pass as reasonable security for an app. All right, so like I say, and you can install, another thing you can do is sideload a real rogue certificate on your device. If I can get you to just click on yes to something, which is not that hard, then you'll install it as a trusted certificate, and then now nothing will complain as I intercept all your stuff. And as you've seen, you can install a Burp certificate on your device to see it. All right, Browser has the ability to run a server and make rogue agents, which is like a command and control server and agents. Now, like I say, Browser wasn't this good at this. The main tool students use is Metasploit. You run a Metasploit server, and you make Metasploit malware that makes Metasploit bots. And if you haven't done that in a pen testing class, I'll add it to this class. We'll do it to some phones. And the main thing the professionals use is Cobalt Strike. Cobalt Strike is the professional server. It costs thousands of dollars, and you have to convince them you're not a crook. And then you can have Cobalt Strike software. You run this, and it makes these malware things to install on your victims that are indetectable and use all the best vulnerabilities. And that's what real pen testers use, and a whole lot of criminals. And you can't get a copy of it to play with. So the closest thing that you can get for free is Metasploit. And we use it in the pen testing classes here, and I'm planning to use it in here. Anyway, so you make malware and you put it on. In this case, it would be make malicious Android apps. Deliver APKs. When people install those, they put me in remote control of your phone. All right. And so privilege levels. If I do get onto your app onto some ability to execute code on your phone, one thing I might get is a shell in the web browser, where I have some ability to control your web browser because you have one of these apps with these web vulnerabilities. This means I can execute individual commands, but I haven't really logged in as some kind of user account. I don't have the environment variables. This is called an app without context. I can execute commands one by one, but I don't really have a session and environment set up. And so I can do some things, but I can't use Java libraries or install packages or read SMS. I can execute some commands. If I can get a non-system app with context, this is what I might get if I'm able to completely take over an app or get you to install a malicious app on your machine. Now I have the control from the viewpoint of one app. And therefore I can do anything that app can do. But most apps don't really have permission to do anything except read their own data. And what's better is if an installed package, so there's where I took over an app, and I can only do what that app will currently do. Here is where I get you to install an app. Now, when you install it, it will say, this app has permission to access your camera, access the microphone, things like that. Then I can do anything you grant me. And in fact, as we talked about, often I can exceed that because the Android granting permission thing has some flaws. But anyway, that's the next thing. And of course, in ADB Shell Access, as we've done here, if you're not root, you can install apps, you can interact with apps. You can do ADB push to install apps. You can interact with apps as a developer. But if you can escalate the system, then you can install apps, change device configuration, get into other apps' data and all that. And that's what you do by rooting your phone and moving up to root. This is, of course, what you'd really like. And the normal way you do it is you go one of those lesser amounts of privilege through some kind of vulnerability, and then you use local exploits to escalate privilege. And the ultimate power is root user that can just do anything, manipulate any aspect of the device. All right, so we got some Cahoots. Let's take a look at them. I got the Saturday class, and I keep forgetting to do the Cahoots. A whole bunch of them backed up. So I'm more confused and think about other things on Saturday. Anyway. This is 128. (128) 8A, there it is. I did not yet lose all my old YouTube lectures. I just expect that within the next month or two, because Google has taken down videos 3 times, and they said both times, if you do it again, we're going to start canceling your account. And 3 times I managed to talk them out of it. But that won't work forever. Well, no, I can't back up all those old things. I've stopped putting more there, but I'm certainly not energetic enough to try to back up all my old stuff from YouTube. The old stuff tends to go out of date anyway. My main concern is to make sure that this semester stays intact and the future semesters don't get involved. There's no sound. Oh, here's the sound. Okay. Missing the sound. Oh. I know. That's right. This is 128. In fact, I think I have almost everything this semester backed up on this device, so I would be able to put this semester back up if they took me down, but certainly not all the previous years. Google might clean up their act and not nuke me, but I certainly can't trust them. So I really need my podcast to be on a different surface than my lectures, because the podcast is what they're getting mad about. I could, but going back to the same people who are kicking me off seems unwise. I moving to a different server seems like a much safer plan. Yeah, I'm trying to navigate the thicketed jungle of wild beasts, like everybody else on the internet. I mean, these things come and go, and they each invent stupid rules and get bought out by different people. Another possibility is that Musk buys Twitter, brings Trump back on, Trump wins the election, then everybody abandons all this and just lets all the Nazis and everybody back on the way it used to be, and then I won't have a problem. Well, I won't have the same problem. I'd have a different problem. Anyway. You never know which way the jungle of the internet is going to go. So what permission do you need for a custom update? I've never seen an app with a custom update, but I haven't really played with very many real apps. I did security audits of maybe 1,000 Android apps though. I did try all the major retail apps. But I did explore their update functionality. But I guess I would have, because they should have noticed I was messing with it and demanded an update, and only a few of them did. Anyway, install packages is what you need. I think they should all at least have had an integrity function to notice if I'm messing with them, and none of them did. But anyway. So what Java class allows an app to load new code at runtime? And that's the Dex class loader, of course. All right. And I see a question. Is the NAT table like an ARP table? Well, it essentially is. An ARP table is at layer 2 and a NAT table is at layer 3. They're similar. Yep. All right. All right. So what intent filter is required if you want to open a URL like home://true? Yeah, that's browsable. And as we saw, I think Fidelity had it, one of the financial apps. So I guess they're putting Fidelity links on their page when you click open in the app, which, might be okay, but I would want to look at that code, because that means I could put Fidelity links on my page that would open in the app, and I could put malicious stuff in there, and I wonder if they thought of that. And from my experience, the odds are pretty high that they did not think of that. All right, so what component may allow a web page to execute Java code? The web views let you do that, and they still let you do that, although in the modern versions, they only let you execute certain special Java functions that you have marked for that purpose, not just all of them. All right. I think we know who these people are. Yes, that's Sean. I think we know who he is. All right, good. So, all right, let's stop this video.